Okay, hello everyone. Good morning. How are you? I hope all of you are doing wonderful. Am I audible? Can I get a little confirmation again? Okay, wonderful. Okay, so welcome back to another speaker session we have brought to you by Insaid, where you will get to have amazing conversations with industry experts. So today we have with us a very special guest, Mr. Vijay Ranjan, and he has been in the industry for over 25 years and has held many positions at many large tech companies like Google and Yahoo, and participated into many talks, giving back to the community, giving all of us great insights. Therefore, he would be the perfect person to speak to you all about how you can position yourself as a data leader of tomorrow. So, without further ado, please welcome Mr. Vijay Ranjan.
Thank you, Harshita, for nice words. And good morning, everyone. I'm here to share some of my experiences, and hopefully, you should be able to get something from this. And well, we take it as we go along because we have just 1 hour. I have some 20 odd slides, and I have a couple of puzzles for you folks. So, Harshita, if you could present first.
Yeah, sure. Please give me a moment. I'm sharing. I hope the screen is visible.
Yes, it is.
Okay. Let's get started.
Awesome. The next slide, please. Yeah. I'll keep this short. 25 years of experience. Started my own company. Worked at Google. Worked at Yahoo, Visa, Snapdeal, Taxi for sure. Very interesting career both in the US, India, as well as in Dubai. All three places. So I'm currently in between Dubai and Bangalore. So just to let you know. Next slide, please, Harshita.
Yeah.
Yeah. My journey is a little important because I think a lot of you will be able to resonate with me, and hopefully, you would be able to do things better than or faster than I did. So just some few things. I was in this app tech class along with my engineering back in 1994, and I wrote my first SQL there. So yes, it'll be my 30th year anniversary of my first SQL next year. I did bachelor's of engineering in electronics, which kind of gave a reasonably good foundation in math, and that helped me quite a bit. I worked for 3 years, 1995 through 98, in software development, pure software development in Mumbai and then later on in the US. And then I did an MS full time from University of California at Santa Barbara for about a year and a half. A year and a half was the duration. That is when I jumped from electronics engineering and math to computer science. But data science was kind of, in some flavors or the other, was always there, right? Information retrieval was a very big problem. And back in 2000, the best company to get into was Microsoft or Oracle. And again, databases was data retrievals were the big thing, right? Subsequently, I got, I worked for 10, 11 years, and somewhere in the middle, you get a kind of a midlife crisis or a mid-career crisis. What am I doing? I mean, I started with C, C++, moved to Java. I'm just changing languages, but what additional value am I bringing to the company? And I mean, what is it that I can add, to my sleeve in terms of a medal? So I took a course in machine learning and data mining back in 2010. I finished most of it by 2011. I think I had one course which I completed in 2013, but it was an online course, and this gave me the first, vitamin B12 in my career to move up. Subsequently, I got to work at Hadoop, work with Hadoop, and I wrote actual Java MapReduce. You guys use Hive, if you do, but I actually got to write a MapReduce job in Java, which is fun to say the least, and it was really interesting. Actually, it taught me a lot. And then 7 years, give and take, I've worked in analytics, software engineering, excuse me, big data, machine learning, unsupervised learning, a lot of clustering stuff. And I worked at well, after Yahoo, I worked in two Indian startups, Taxi for Sure and Snapdeal. Again, I got a lot of exposure in Snapdeal and Taxi for Sure to data science, and I was able to do a lot of wonders, at least to my career at that point. And I'll share some of those insights there. And 7 years, give and take in data science and analytics. So yeah, that's my journey, and I think you would perhaps you would be able to resonate with something similar, maybe in a shorter time frame in your careers if you've already started working. Next slide, please, Harshita. Right. So I'm going to talk about different roles. Well, the session today is going to be about different roles, the skills and training needed, the right mindset, job and career, how to position yourself in a company, job and career. What should you do to remain relevant? Right? And then I'll do some puzzles at the end because I think you'll understand where I'm coming from, and you'll probably take your courses at Insaid very seriously, and you'll understand why it's important to quantify some of these things. Next slide, please. Right. So we can run a quick poll. Harshita, how do I run this poll here, or would you be able to run it for me?
It's the question, and people can answer in the chat, no problem.
Okay, people can answer. Okay.
Also, there's a request from the students. Can you please be a little louder? I think there's a problem in hearing.
Okay. Is it better now?
Yeah, it's better, much better.
All right. So I'm going to ask this question. How many of you taking this course have done science with math, physics, stats, econometrics, or science without math and stats, and basically just biology, psychology, or chemistry? How many of you are humanities students? How many of you are business studies? I'll just take a quick poll on the chat because I'll tell you why this is important. You need to position yourself carefully in your career, and then you need to be also very patient with yourself. So let's say you studied biology and you did not do maths after 12th standard or 10th standard. It's not going to be very easy to become a pure data scientist, right? So I think that positioning yourself, learning slowly, taking courses, and really doing what you want to do is important. So physics, chemistry, biology, somebody MPC, maths, physics, chemistry, I think. Yeah, so quite a few people, some of you have studied business. Now that makes you a very good candidate for business data analytics and product management. So positioning yourself with the skills is very important. And medicine, wow. Medicine is also fantastic, commerce background. Yeah, so if you're commerce, if you're not maths and science in the true sense, as in physics, chemistry, or physics, maths, stats, econometrics, then what happens is, what happens is that you will actually, you may actually find it very hard in the data engineering and the pure data science space. But that doesn't mean you cannot do it. It just means you need to give yourself more time. You need to be a little more patient. You need to take more courses. And the path will be a little longer, right? If it's 2 years for a person with maths, physics, and econometrics and stats, then it's going to be probably 4 or 5 years for you because you're going to catch up. So that's the poll. Harshita, next slide, please. So I'm going to tell you about different roles in the data industry. And again, distinguish, next slide again, distinguish between a business side person, oh no, the one before, yes. Distinguish between a business side person and somebody hands-on, somebody writing code, somebody making visualization, somebody presenting, somebody telling a story, somebody doing ML ops, that is actually deploying models in production, monitoring it, ensuring that the drift, data drift and concept drift don't affect the behavior of the model. So there's data consumers, there's data analysts, data scientists, business analysts. The data consumers could be the BCom and the commerce and the non-maths, physics, stats people. Same with the data analyst, right? So the first two green boxes could very well be your career path. And in fact, there are more jobs in the data analyst and the data consumer space today than there are in the pure data scientist. Actually, even the business analyst is someone that you could fit into very well. And those who've done engineering and the STEM, that is science, technology, engineering, mathematics, you would fit into you could fit into any one of these four. But for those who are non-STEM, I would recommend try to go easy on yourself and do business analysis, being a consumer of data, looking at an insight. Should I spend more money in marketing or not? That's an easy decision to make once you have the data, right? And being a data analyst. So, but those with STEM, right? Data scientist you can aspire to be a data scientist, and the journey is not as hard as non-STEM, but it is hard enough. Next slide, please, Harshita. So, if you compare my journey, I started as a programmer, 3 years as a software engineer again. So, from a programmer, I became a from a software engineer, I became a data engineer to the box below. In the data engineering, again, it was Hadoop, Spark, a lot of Hadoop back in the day, 2012, 13. And it required a separate mindset of understanding data and writing code. So from a software engineer going to data engineering was not as hard, but I did need to know a few things, a lot of concepts on MapReduce and so on. From there, I was not a statistician, but I did take a course in statistics, and I think I understand statistics really, really well. For example, in terms of hypothesis testing, in terms of communication, what is confidence interval and margin of error and so on. So I spent a lot of time studying statistics, which I think a lot of people in the audience should do that. It's a very important subject, and I'll talk a little more about it as we go on. And then there's this machine learning scientists who are basically, typically I've known them to be PhDs, or they have a master's in physics or computer science, or some engineering, but it's core STEM. Most of them PhDs, some of them with masters. So yes, that's kind of the landscape of the kind of people you have, the career paths you can take. Next slide, please. Now, if you go to any organization, let's take a FANG company, right? FANG as in Facebook, Amazon, Apple, Netflix, Google, Microsoft, and so on. Some of these big companies. Their organization structure could be quite different from, say, a 400 people company or a 100-person company or a startup, right? But give and take, the roles are something like this. And in your careers, you could end up choosing to be one of the few written here. So the first one is product manager, product managers, and the business team. This is a very critical role. And if you've been following careers, Sundar Pichai, the CEO of Google, started his career in Google as a product manager. Very important role. Decides the roadmap for a product. Of course, not alone, but he's kind of she's kind of the DRI, directly responsible individual. Very important role. Now, I've known software engineers who've moved to product manager role. I've known data scientists and data analysts also move to product management role. I've seen QA, quality assurance people, also move to data science, product management role. So very important role. And the product managers today need to absolutely know data science and have data science skills, which was not the case maybe about, say, about 8 or 9 or 10 years ago. So that's a product manager. Then you have project managers. Project managers are typically people who have a PMP, project management certification, professional certification. They they follow either the waterfall model, or they are the advocates for the waterfall model or the agile model in a company. Another very important role, I've known people, and don't underestimate this one role. I know engineers kind of tend to look down upon this a bit, at least initially in their careers. But this is such an important role that people who do project management bring everyone together during the execution of the project. And having knowledge of data science for a project manager has become very imperative. For example, they need to know what ML ops is and what is the deployment of a model, and so on and so forth. So again, very important role. And of course, there's software engineering. Many of you know what this is. I won't dwell too much into it. There's data engineering. There's data analysis, the analytics team. There are data scientists, and then there are ML ops. Um, ML ops is basically DevOps plus uh, machine learning, and some software engineering skills, data engineering skills. Uh, Kind of a new role, because deployment of models is quite different from normal deployment of software. So let's say I made a change. I was in Yahoo Mail, I was in Gmail also, I mean, related to Gmail, but I was in Yahoo Mail specifically, and I made a code change based on a requirement. And then I pushed it to production. Uh, Now that would be a software engineering, process. There's development with unit tests and integration tests. Then there's QA, and then there is a rollout with 1%, or only in our silo where we dog food our own work. And then once it's fine, then it's pushed across to all the servers. In the case of machine learning, it's not that simple, because machine learning models are not long lived. For example, suppose you were predicting fraud, right? Let's say in an insurance company. Um, the Once you stop catching fraud, or once you start catching fraud, many of the fraudsters would try to masquerade or come another way and do fraud. So, which means your model has become stale. This model needs to be, a new model needs to be built and put into production, so that you you remain fresh, right? The model remains fresh. This entire process, including the measurements, requires something known as ML ops. Uh, could you? Okay, I could be in the screen. So ML ops is a very important field, new emerging field. So many of you who are software engineers could also transition to, or data engineers could also transition to ML ops. Yes, next slide, please, Harshita. Right. So kind of give you the flow as to what happens in an org. Uh, it's again not written in stone, but just to give you an idea, it's kind of like this. The product manager walks up to the data scientist after getting prior approvals from higher ups in the business team and so on. So point number one, the product manager walks to the data scientist and says, listen, I need you to do this, whatever the roadmap presents it. The product manager would also rope in the data analyst, and maybe also the project manager, which is in yellow right here, but not necessarily upfront. So after ironing out all the details in one and two with the data scientist and the data analyst, the data scientist and the data analyst may also talk to each other to better understand things. And they may scope out, like, uh, what data do we need for this project? Where does this data sit? Excuse me. So that's when the data scientist would go and talk to a data engineer, and the data engineer would say, yeah, this data sits in this file location on Spark, right? And these are the fields. This is the schema, or this is unstructured data, whatever it is, right? And the data scientist would then also initiate talks with the ML ops to provision the servers, or just find out, where can the deployment happen whenever they are ready. So after 4 and 5 and 6, ML ops and data engineers talk to each other quite a bit to know the location of the data. If it's a automated model building, so then data comes in, you sample the data, you build your model, and you deploy it. And there are places like in internet advertising where models are built every 15 minutes or even faster. So they need to talk to each other, the data scientist, the data engineer, and ML ops. And then that's when the data scientist goes with the team and focuses on model building. Um, Once a model is ready and they've measured accuracy, they take their results and after a certain amount of confidence. And confidence comes when you follow the right methodology and you're convinced that the model will stand at least some test of time, right? So, the data scientist will go to a product manager and say, I'm ready, like, let's deploy this. And the product manager, or I'm ready to build it, and I'm ready to do something. I've scoped it out in terms of tasks and tickets. And then comes in the project manager. And the project manager is basically the orchestrator, like, pretty much of the entire process of development, deployment, and so on. Now, when you're studying data science, remember there are so many roles apart from a data scientist who are so key to the success of projects and teams. So don't feel that you only need to be a data scientist. There are other I won't call them peripheral. There are other roles that you could fit into very easily. Next slide, please, Harshita. Okay. Now, just to test your understanding, I want to know if you guys can answer this question. Who builds dashboards? Is it a business data analyst? Is it a data engineer? Is it ML ops engineer? Applied data scientist? Yes, I think overwhelmingly people have said data analyst. Very good. Next slide, please. Who builds reports? Correct. I think most people have got this right. Again, data analyst is the one who builds reports. Next, who deploys models? Correct. And most people are getting it right. ML ops engineer and the applied data scientist. They deploy it in production. It's more the ML ops person, but the applied data scientist is present to monitor things and see if things are working fine. Next question. Who collects data? Correct. Most people are answering it right. Again, it's the data engineer responsible for the location of the data, collecting it in a timely fashion, and so on. Next question, please. This is interesting. Who assures data quality? It is a collective responsibility. It's all of the above. Data quality is very important. So it's a collective responsibility. If something breaks in production, and let's say I am an ML ops engineer, and let's say it was because of data quality, I cannot go and tell the super boss that, hey, that's not my responsibility. At the end of the day, data, the success of the team is means everyone has to be contributing successfully. Next slide, please. Who brings data into storage for consumption in a timely manner? Next question. Yes, data engineer again. So the second option. Next question, please. Who monitors data distribution? This is an interesting question. Actually, most people are getting it wrong. I would say it is the business data analyst and the applied data scientist. And I'll tell you why so, because of the skills. Again, a data engineer is more than welcome to also volunteer to do this, but data distributions, especially done to measure data drift in the models, requires knowledge of statistics. The business data analyst and the applied data scientist, point number one, would be the right answer. Next question. All right, next slide. Skills and training. Just minimize my window a bit. Yes. So what I've done is I've taken skills that I am familiar with, right? I sit close to whenever I visit Bangalore, I sit with a friend who runs a company, a data science company. So we discuss skills, we discuss on hiring, and we discuss all of these things quite a lot in detail. And one thing that comes out is when we are hiring freshers from college, we do not get the skills needed or the desired skills needed immediately. And some of these things cannot be taught in college because curriculums do not change with time. For example, ChatGPT or something to do with ML ops, right? It's relatively new. It's less than 3 years old. And college and university programs do not have these kind of courses. And so there's misalignment between the industry and university. So knowledge of advanced SQL, I would say that business analysts should definitely know this really well. Data engineer and data scientists too. I personally think that SQL, as I mentioned, right, I've been writing SQL for the past 30 years. I think it should be taught in the second year of university or first year even. Everyone needs to know SQL to some degree, but advanced SQL is something that a business data analyst should know really well along with the data scientist. In most cases, you're just aggregating or you're just doing data retrieval, but knowing how to do a join, how to put where clauses, how to play with, how to do use aggregate functions, all of this is really important. The next thing is storytelling. And I'll tell you, it is such an important skill. I underestimated it, right? And most people from the STEM field, most engineers, they tend to underestimate the importance of storytelling. It is one of the most important things. And again, a business data analyst needs to know it really well, and to an extent, even the data scientist. Visualization, again, good PPTs. I've had one report of mine I can't name the company, but she was so brilliant at presentation and visualization. She made my life extremely easy when I had to make a strong case with my peers for something. And she would give fantastic presentations as well. Visualization is extremely important. Folks, don't underestimate it. For the non-STEM people taking courses, let me tell you, you probably have an added advantage because I've not known engineers to do very well in visualization and presentation. So that's, if you've got an added advantage, make the most of it. Clustering and unsupervised learning. This, obviously, a data scientist is supposed to know this really well. But what is happening increasingly is that companies are getting impatient, or they're investing so much in the data science and engineering and data analysis field that they're saying that show me the insight. I mean, they get very impatient in terms of, I need to know the insight. Should I do the sale or not? Or I don't even know my data. So a lot of that is getting pushed from the data science world into the data analysis world. So increasingly, I'm seeing that folks are learning clustering and unsupervised learning, and the business data analyst has to pick this up. I think over a period of time, it would change from a 6 to an 8, I think. And you don't need to know fancy math, because today most of it is just calling some Python function or doing something in R, it's going to be much easier moving forward. You don't need to know the math behind it. You don't need to know Fourier transform or anything fancy. You don't need to know calculus. You don't need to know um, matrix algebra, linear algebra, and so on. Model building and regression. Again, mostly a data scientist thing, but I encourage data engineers, ML ops, and analysts to study this. You'll get an idea as to what's happening. Product managers need to be informed on what a classification model is, what's the accuracy, the precision, the recall, the F1 score, and so on. Then model monitoring and performance. This is something ML ops definitely needs to know. So that's somewhere, at least from an engineering standpoint, you need to be able to gather statistics on the performance of the model. Data drift and concept drift, another thing that ML ops and data scientists need to know. Python programming, I think what's going to happen is maybe in another 5 years, a good percentage of the world, of the younger population, would know Python. So it's a given, right? You may not be a data scientist also, but you may know Python. So Python programming is definitely something that everyone should know. Next slide, please. Now, when it comes to data pipelines, microservices, Kafka, RabbitMQ, all of that, right? Cloud. The data engineer and the ML ops engineer need to know this quite well. The data scientist, a little bit, yes, but mostly it is the data engineer and the ML ops engineer. Studying about data quality, as I said, it's a responsibility that everyone shares. So any courses on data quality is something that everyone should take. It should be a mandatory course, in my opinion. Statistics and probability. Let me tell you this. In 2010, when I took the course in statistics, I hated it. I did not understand it. I just, I'd done it in engineering and everything was mean median mode. But the real power of statistics, and it comes in linear regression, in hypothesis testing, study of probability, learning those distributions and applying them in real life problems, in actual real life problems. And you'll see that, later on in my talk. Calculus, numerical analysis, linear algebra, definitely something that a data scientist should know. Others, out of curiosity, you could keep up to date every, it's a good part-time project. So I've known data engineers and MLOps engineers who aspire to be data scientists, who've taken a lot of these courses on calculus, numerical analysis, and linear algebra. And what they do is they work on models on the weekend or in their own personal time. And it's a fun thing to do. It's very comforting when something works. And I can talk about various kinds of problems. They probably take part in Kaggle competitions as well. The next one is domain expertise. Definitely something that a business and data analyst should know, which to a reasonably high extent, even the data scientist is expected to know the business of the company. And what happens is that typically the management talks to the data scientist, who is an expensive resource. Excuse me. And if the data scientist is not able to understand the business and communicate, then that's a big letdown to the management. So, but data analyst, definitely domain expertise. Data scientist needs to know, maybe this 5 will change to a 7 in terms of expectations down the road. DBMS and NoSQL, definitely the data engineer and MLOps engineer, and to some extent the data scientist. Hadoop and Spark, again, a data engineering thing, right? And MATLAB, R, formulation, and so on, proofs, experimentation, again, the data scientist. So these are the kind of skills I feel that there could be more, and this is evolving. So this is a snapshot given by Vijay in 2023, in May of 2023, right? So this could change over a period of time. Next slide, please. This is kind of the same thing shown visually. Now, you can see, just, I spoke about visualization. You can see how beautiful this visualization is compared to that table. Excuse me. The table is objective, but the visualization is, you know, uh, an image is 1,000 words, right? So a picture is 1,000 words. So this kind of explains what a data analyst is, what is the specialization of a data analyst, what is the specialization of a data scientist, a data engineer, and machine learning engineer, right? All right. So now I will talk a little bit about why do teams fail and what really spoils it for teams. Um, I have seen that, and I've seen this especially in startups, the problem or the project intent is not clear. The first thing, I mean, leave it, forget about data science. In anything that you do in a company, the objective and the clarity of the problem is paramount. Without that, I think you have set off on the wrong path. So the sooner you come back towards, the sooner you come back towards the asking the right question to the project, the better you are in terms of success. Now, next one is, even if one of the roles does not play their parts well, do not play their parts well, the team could fail. So let's say I'm the data engineer in that ecosystem that I showed earlier, and I don't provide data on time, or I've given the wrong path to the files, or I've given some old archived data saying that it's new. Obviously, the data scientist is going to build models based on that, and it takes quite a bit of time building models. And because of me, the data engineer, the whole project is going to be, will be deployed incorrectly, right? So that's another very important thing, that everyone should play their role well. Lack of clear roles and responsibilities. Now, this is really hard, right? I remember in one company back not too long ago, but when I was building models, there were other engineers who were really liking the models that I built, my team and I built, and they thought that they could play better. And as a result, they did not go and complete their jobs on time. And then the same thing was being done by two people. So having clear roles and responsibilities, and having DRI, right? Directly responsible individual. So Vijay is directly responsible for model building, or Vijay is directly responsible to be the project manager for this project. So the roles and responsibilities need to be absolutely clear. When you have, say, 7 or 8 freshers working together, everybody wants to be a data scientist. Nobody wants to do ML ops, right? No one wants to be a data analyst. Everybody wants to be a data scientist. So clear roles and responsibilities, very important in an org. Bad handover. This is another problem where I delay, and the whole chain after me gets delayed, or I give something incorrectly. And when I say I could be a data analyst, I could be a data engineer, I could be an ML ops engineer, or even a data scientist. So bad handover and poor communication also between individuals is something that happens quite a lot. So why I'm talking about this is, next slide, maybe down the line I could speak a little more about it, but soft skills are very important, and clarity is very important in good problem solving. Next, let's do some puzzles. I'm going to do a quick check of time. I think we are doing well in time. Okay, now think about this. I want to see answers to this one. Puzzle is, given a coin with heads and tails, right? Just heads and tails. Which of the Under which of the following cases would you confidently say that the coin is biased? Please read all the options. All right. Most people are saying one. Some have said none of the above. Some are saying four. I would say yes. The answer seems to be more. The best answer in this lot is four. And why is that? It was matching your intuition, right? Statistics is intuition. This very problem can be solved in using, so percentages is wrong. Ravi Mishra writes percentage. Let me tell you something. 7 out of 10 is 70%. 70 out of 100 is 70%. Both are 70%. But in the coin toss example, if you got 7 heads out of 10 tries versus 70 heads out of 100 tries, think over again. You would think the answer is 70 over 100 rather than 7 over 10. Yes, more the experiments, more the confidence, right? So binomial distribution and chi-square tests are used for this kind of thing. And you should pay attention. If you understand this, if you feel this internally, then you've understood the story of numbers, and you're in a position to understand statistics really well. Next puzzle, please. All right. Interesting question. I don't know how many of you saw the Karnataka elections, and it was really interesting to study Karnataka elections. And there were poll numbers put out, right? Different news channels were telling that, this party is going to get so much and that party is going to get so much. And eventually, a lot of them were wrong. But let's see. This is a sensitive question, but let's say, is there if somebody asks you, is there a dependence between religion and political party? And you say yes. No, Tushar, don't just say yes. Think about it. Based on the data. Based on the data. That's very important. Based on the data. Now, I've given you two very simple tables to the right. Look at these two cases. The first one and the second one. Which of these would you say is, in which of these cases would you say that religion is statistically, related to affiliation to a political party? Nobody is answering. No, which one? First one or second one? I mean, is the first one, does the first one show affiliation? The first table, that is religion 1, 2, 3 in political party AB. Both are similar. The first one is more when compared to. Looking at the data. Actually, and thanks for trying, but the answer actually is the second one shows political affiliation. Shows that yes, political affiliation is dependent on religion. The first one does not. Okay. Now there is a tipping point number after which your confidence says yes, there is a relationship. Before that number, you will say there is not a relationship. So very important thing. This is done by chi-square test. You learn this in statistics, and even as a machine learning or a pure data scientist, a lot of the feature, I won't say feature engineering, but when you're working with features and you want to see if two categorical variables are related, you don't need to pick both. You need to pick only one. That's in feature selection, that is. Then you would use chi-square tests. So don't underestimate the power of statistics. It is very important in machine learning. Next slide, please. Puzzle 3. This one is a little easy. How many of you think that this last point is a spike? So would you consider this, data is going like this in a line chart and suddenly there is a spike? Would you consider this a spike? Most people agree. Yes. Why? I saw somebody answer yes and data. Well, I think Naman, it is yeah. The answer is yes, but your reasoning is also right. Though you said no. Naman, I think Naman N. Yes, it is an outlier because it is two standard deviations from the mean. Assuming that data is like a bell curve, again, you learn this in statistics. Imagine without having to click and see so many graphs, if I know which one is spiking based on the 2 sigma property, um, I can automatically know which data which data item is spiking. No, is are sales suddenly spiking in Kolkata? Right, I'd come to know that without even looking at it. So uh, this there are yes, it's outliers, and the way you find that out is using the 2 sigma rule, more than 2 standard deviations from the mean. Uh, Next puzzle, please. Okay. Puzzle number 4, without seeing this time series graph. So forget you had this chart and I just gave you these numbers 100, 110, 120, 130, all the way to 199. Can you say mota mota? I know I'm using colloquial words, but more or less, could you say that there is some sort of linearity in the data? You can, right? You didn't have to click on the graph to know that, correct? You did not have to click on the graph to know that. You cannot click on every visualization, drill down and see. The way you find this out again in an automated fashion is something you should learn in statistics, known as linear regression. With linear regression, you can compute the slope, and first of all, you can say whether the points are in a line, and the confidence would be if the correlation coefficient is either -1 or it is +1, more closer to 1 and or closer to -1. So typically, there's a rule of thumb that if it's greater than 0.75 or less than -0.75, then there's linearity. Now, imagine this: if you had data in time series data, and you wanted to find out if there is linearity anywhere, you could easily write this linear regression with slope computation and with the just functions. It's available in Java. It's available in Python. It's available even C++ libraries have it. So you could become a hero in your company, and say that, hey, this particular client of ours has been spending a lot of money over a period of time with us. We should take care of him. Or this client has engagement with us has been decreasing over years, and no one even noticed. So you could do that and get some brownie points in your company. So next slide. So I hope you get the gist of this puzzles, and we're doing okay on time. I will try to keep this quick. Most of you may want to take screenshots of the next slide. Next slide, please, Harshita. Not this one, the one after that. Well, I'll talk about this. Yeah, just go back up. Again, nothing is impossible if you're passionate about data science, and let's say you've done biology or you've done, I don't know, commerce, business, and you want to transition into a data scientist. You just have to give yourself time. So be patient. These courses are foundational courses. You need to do this with the intent of really, more than just getting a job. At least you should feel happy that you did this, that you understand these things really well. You should be able to apply it in your day-to-day life. Pursue your passion. Let no one tell you that you cannot do it, because I know it gets very discouraging. 2010, when I was reading papers, and again, after 10 to 15 years, I was seeing integral signs and summation signs and formulae. I used to break out into a sweat. There was logarithms, and even now when I see some of the linear algebra formulae, I get really scared. So you just need to be patient, right? So put your time, invest your time, convince yourself, ask people when in doubt, and you can progress. But I want to give you a caveat. Let no one come and tell you you cannot do it, but you should know whether you want to do it or whether it's worth your while. So let's take an example. Let's say you're a data engineer and you've just been doing data engineering for 5 years and you want to become a data scientist. And let's say you're kind of in your mid 30s and you have family responsibilities and so on. The journey realistically is hard, uh, if not impossible. It is not impossible, but it's hard. That's when you make a call that, you know, what should I transition to? Maybe you should move to ML ops or go back to software engineering, or maybe try to become a product manager, take courses for that. So I think that attitude is very important, and knowing what you can't do in a fixed duration is also something that you need to learn, so that you position your career correctly, right? I mean, I've known people who's come and tell me they want to be data scientists and they've studied chemistry, and they've got family and kids, and, you know, old aging parents. So, and they really don't have the time to invest. So they cannot, if unless they put the time. So it's not going to be an easy decision. Uh, but in career counseling, we never say that you cannot do it, but we want you to answer whether should you do it or not. Excuse me. And then, uh, as time increases, the minimum knowledge required will also increase. New tools will come, new programming techniques would come. You just have to be up to date. So that's another thing that I'd like to tell you, that keep taking courses on and off. And then I'm doing one right now, and something pretty advanced. So I break out into a sweat when I try to do that math. And then sometimes I give up, or I just call a friend who's a scientist and he helps me answer these questions. But yes, you need to be upgraded. And soft skills are needed everywhere. Uh, at Google, the SVP Urs Osley had this, no jerks policy. Now, Urs himself is such a genius, has got so much contribution in Google, 25 years in Google, and he was a brilliant professor in UC Santa Barbara, a PhD from Stanford. He was a professor in Santa Barbara when I studied there, and he has this really beautiful thing that says "No jerks, please." So be nice, learn to fit in, be respectful. Next slide, please. Okay, now this one you may want to take a screenshot. Many of you may want to take a screenshot of this. But basically, I've tried to put, if most people want a career transition. For example, somebody may not want to be a data engineer for all his or her life. They'll get bored, right? Maybe 5 years, maybe 10 years, and then try something new. So there is this transition matrix that I put together, and you can transition, say, from an ML ops to a applied data scientist, but know your journey, right? Know the skill set. It may take you 5 years, and after that, somebody is going to give you a job as a applied data scientist in the company or in some other company. I don't know. So you need to weigh the pros and cons of this. What blank means, a software engineer would not want to be a software engineer. I'm just putting it as blank, stating that it's unlikely that somebody who is a software engineer would want to become an analyst. I'm not calling it a downgrade. It's just that the likelihood is much lower. So yes, you can, but I picked up the ones that most people want to transition from and to. I hope that helps answer your question. Next slide, please. the right mindset, handling FOMO, fear of missing out. Can you just go back, please? Harshita, could you go back one slide? Handling FOMO and drinking selectively from the fire hose. Now, next slide. Now, I'll share one thing that happened to me and my friend, quite a few people. You know, on LinkedIn, you have these people who promote cheat sheets of data science and system design or top 10 machine learning algorithms, various things, right? Now, what happens is the information coming there is not immediately relevant to you. And your insecurity, your fear of missing out, you may end up not living a life. You may end up just keep studying and learning and random things, right? This happened to me a few years ago. This happened to quite a few friends of mine. I think to prevent burnout and to be psychologically fresh, it's very important to have just the right amount of FOMO and not too much of it. Beyond a point, it gets very dangerous. You won't be able to sleep properly, and it just does not just affect you; it affects the lives around you. So that's one thing. Rate of newer libraries and new tools coming is increasing exponentially. So you cannot keep in touch with everything, right? Even God cannot, right? It's just way too much and it's wasteful. So you need to cherry pick. You need to take a course a year. Some of these courses that are there, like Insaid, so many other courses, they've been created with the intent of keeping people, upgrading. So take a course a year and an overview course. Now, currently, ChatGPT, Bard, Transformers, generative AIs, they are totally exploding. One thing that I've noticed is that this could need an overall in your mindset in terms of what you can do with data. So being able to appreciate these kind of things requires a lot of your own personal investment. And also you need to become aware to the right amount so that you can do something with these. So again, balancing new information with with a life is very important. You cannot just keep studying. You just cannot keep studying everything that comes your way. You have to cherry pick. Currently, it is Chat GPT and Bard. So pick one topic a year which is trending, so that you can, you can really make something of your career. You can stay up to date and yet not have a burnout. Next slide. I think we are done. Yes, Q&A, please. I'll stop that.
Yeah. So are you able to access the Q&A, or should I just copy the questions in the chat? Whatever suits you.
I can access it.
Okay, then. Wonderful.
Please provide good references to learn statistics. Actually, you should take a course. There is a book. It's got a shoe on it. It's by Michael Sullivan 3. Don't download the soft copy. I think it's available free. Buy the book. It is a big fat book. I really like that book. I think if you solve the unsolved problems and read the solved problems there, you would really appreciate each of those hypothesis tests and all of that, right? Estimations and so on. So that's the book. That's the book I use, and I think I learned statistics well because of that. Next question: what is the future of MLOps team? MLOps is DevOps 90% or maybe 80%, and 20% the process of data science, right? Deploying models. In a FANG company, you definitely would have a good scope future for MLOps. If you're in a startup, not as much. Yes, possible, but not as much. So there is scope. It is very important to know what MLOps is and how it works. I think for the next runway for the next 4 or 5 years, it will be relevant. That's my take on it. Next one, Anand Patel. With all due respect, the career path or role can fetch me minimum. I started my career with 5,000 rupees. So I don't know this, Anand. There will be, HR job recruiters who would be able to tell you this. But yes, a fresher in a FANG gets about 15 to 20 lakhs. So career path, software engineering, data engineering, ML ops, uh, will be you'll be able to learn these sooner and achieve it soon. Achieve a job of 15 lakhs and above. If someone,
Sorry to disturb Mr. Vijay. Can you please repeat the statistics book name? I think a lot of people want that again.
I'll send it to you. It's Michael. It's I think
Yeah,
data.
Fundamental of Statistics by Mike Sullivan.
I don't think it's fundamental. I think in the one uh, making informed decisions, decisions
Okay.
in statistics. The Michael Sullivan, the one I have is the one with the shoe on it.
Okay. I hope that clears everything, guys. Yeah.
Yeah.
Please continue.
Yes. If someone is working as a data engineer, should they continue on this field and learn more cloud technology, or? Good question. Neha, this is a very good question. I won't study something because uh, it's trending. I will study something because I am bored of what I'm doing and I want to explore a few more things. So this is a very individual question, but it's a very important question. The transition from data engineering to cloud technology is significantly easier than cloud data engineering to data science. If you take courses and patiently take on small tasks and work with a data science team in your company despite being a data engineer, so maybe talk to your manager, get a 80-20, 80% I'm going to be working as a data engineer, 20% as a data scientist for the next 2 years. Can I do that? If you've built that rapport with your boss, then definitely you can move into a data science role. Again, data science requires mentors. It requires a senior person. So if you have that and you're interested and you can do the math, then definitely you may want to consider. But the transition from data engineering to cloud technology is definitely much easier. Is Python going to be replaced in the future, Devata? Um, I don't think so. The number of libraries available in Python are just phenomenal in the data science space. So there could be competitors to it because the performance has been of a concern quite a bit, right? I mean, I started my career at C++, and when I went to Java, people were already complaining that Java is pathetically slow. And then Java had a lot of improvements like just-in-time compiler and so on, and became pretty fast, and hardware speed also improved. So as a result, Java stayed on. But that said, I was just talking to a very good friend who's an SVP in Z5, and he was saying Skylar DB was basically a rewrite of Cassandra using C++. And Cassandra, I think, was written using Java. So my parallel with that is Python will not go away. New things will come. And Skylar DB re-implemented in C++ works much faster than Cassandra. It's got a lot of performance benefits. So depending on the nature of the problem. Being a mech engineer, how do I stand out while applying for jobs? What are employers looking for? It's not an easy question for me to answer. if I'll be honest, I won't take a non-electronics or non-computer science person for a software engineering job, fresh out of college, leave alone, ML ops or data engineer or data scientist. So I think skilling yourself doing projects, and then there may be companies where you could get a slightly lower pay, like a startup, and maybe spend a year doing that and get that on your resume and actually start working on it, right? So don't try to get a 15 lakh plus salary from day one uh, when you don't have the skills. Sometimes an easy ramp up growth is very important. So I hope that answers your question. Next one, can you elaborate on the importance of MATLAB R formulations and proofs and their use cases in data, as a data scientist? When you're a researching data scientist, and let's say, uh, just look at this. Just keep R and MATLAB aside. MATLAB, of course, is important for a lot of experimentation. So is R, but the formulations and theoretical proofs are very important when you're releasing something new. Now, when I was at Yahoo, around 2012, um, there was this Lee Rhodes, a scientist at Yahoo, had create something known as theta sketch, which was very similar to hyperlog log. Um, and it kind of is like Bloom filters. Now, you need theoretical proofs for Bloom filters, for hyperlog log, and theta sketches. You also need experimental proofs, right? So formulation and all these things become very critical if you become that kind of a data scientist. Now, Google, Amazon, they have these kind of people, the VP of research in Amazon India, Rajiv Rastogi. He's published papers with Sergey Brin and Larry Page, right? So I think it's important if you want to do some publication in your life, then proofs and formulations are important, and you will also end up spending a lot of time with MATLAB and R for experimentation and validation of for your papers. More non-technical experiences, please, like day-to-day life working. I'm not sure I understand this question. Do you understand the question, Harshita? More non.
You can skip to the next one. We'll take it at the end. No problem.
Okay. What is your idea of ML and AI in drug discovery? Absolutely important, Sanjay Malhotra. Absolutely important. In fact, I know somebody who recently left a company in Abu Dhabi, and he moved to Google uh, in Switzerland. And his team in Abu Dhabi was actually doing drug discovery and using AI and ML in healthcare. And they were working on the genome data. So absolutely, the possibilities are endless, and you're not the only one thinking about it. As we speak, about maybe 1,000 people in the world are trying these, or maybe 10,000. And if you manage to succeed and make products fast with this, then you will have a one-upmanship in the game. You'll be ahead in the game, if you know what I'm saying. I'm a program manager and have been a product manager in the past. Can I transition to AI/ML? Yes, you can. Yes, you can, Praveen. Absolutely, you can. It needs time. You need to take courses. You can. Do startups have a demand for data analyst role? Not as much. Not as much. It's mostly in companies in Mumbai or maybe in Delhi, you would find quite a few roles for data analysts. Maybe some in Bangalore, but wherever there's consumption, you'd find a role for data analysts. As a management graduate focusing on HR domain, what would be my scope in data science, machine learning? HR domain. So I share a room with a friend who's got an AI driven tool for predicting employee churn or employee attrition with using AI, and it's in the HR domain. But net understanding data. I think you need to use data science and data analytics in the HR domain, uh, employee health, employee happiness, retention, uh, competitor analysis, right? All of these, maybe not as much ML if you're building something. Yes, if you become a product manager in a company like uh, um, success factors, and you're a product manager, and you're one of the products may need machine learning in the future, so that kind of knowledge becomes handy. But if you're purely in the HR, if you are an HR person, then using data becomes important. So data analytics becomes critical. Maybe not machine learning and NLP at that point, but something more so data analytics. I hope that helps answer your question. How to do practical projects as academic projects are generally. Ooh, good question, Reshma. I think Kaggle, uh, uh, you know, having Kaggle medals really helps. I think people do consider them candidates with Kaggle medals as good candidates. um, Practical projects now with Chat GPT, I think the world is just opened up. So the answer to your question in recent times is ChatGPT and Bard. Next question: what is the scope of a commerce student? Priyanka, move towards analytics. If I absolutely move towards analytics, I think that's a good career path, and you can even transition into product management or project management with commerce. If you try to become a data scientist, the math could be overwhelming, and you're kind of going back in time like 5-7 years and studying it from scratch. If you have that bandwidth and if you're really interested, you can do that. Down the line, after 5 years, how data science roles will be? I think data science roles, Mrinmoy, data science will kind of get absorbed into software engineering. That's my take. Okay, and there are people who have a completely different view, but that's my take, that more will be expected of a software engineer, because breaking roles into data engineer, data scientist, I think companies will lose their patience. HR, only big companies would have that kind of a separation. Startups, pretty much everyone will do everything, right? But for a given project, you'll have roles and responsibilities. Next question: how agriculture will impact it? A lot. There was a company in Bangalore that was predicting the quality of wheat by just scanning the phone. So huge impact, right? There's, I mean, so many things to do in agriculture, and so many fields with AI and ML. What do you suggest for experienced person who is fresher in data science, how he pursues transition? So please look at my transition matrix. I would say that start there. Some things are hard, so you need to test the waters, right? It's like touching a pot, if it's hot or not. So you need to start there. If you can do the math and the stat and the probability, calculus, linear algebra, and you can write programs, then you can move to data science and ML jobs. Keep an eye out for the kind of roles. I think there are, it's clearly there are more data analyst roles than data science roles. And being a programmer, if you've been a programmer before and you're moving to data analyst, then you could have the added advantage that you could get onto the keyboard and do some things fast, which a normal analyst would not be able to do. So I hope I've answered all questions. I know.
Yeah, okay. So thank you so much, Mr. Vijay. It has already been a little over the time. I hope you enjoyed the session, and I hope all of the other students and everyone who has joined enjoyed the session. And from myself, as well as from the entire team of Insaid, thank you very much for the session. It was very insightful. And yeah, so I'm looking forward to more future events with you.
Absolutely. Good luck.
Okay.
Good luck to all the students.
Okay. Wonderful. Wonderful. Thank you so much again.
Bye.
Okay, guys. Bye-bye. And please fill out the feedback form that is in the chat, guys. That's really important for us. Okay. Thank you, Mr. Vijay.